Hey guys, Mr. Milton here. Today we're going to talk about proportions in triangles. Okay, at the end of this video you should be able to set up and solve proportions using the side splitter and angle bisector theorems. Okay, recall set up a proportion and solve for the variable. The horizontal lines are parallel. Okay, so PS is parallel to QR. First of all, why are these triangles similar? Okay, parallel lines always make me think alternate interior angles, corresponding angles, same side interior angles. But in this case, we should have some corresponding angles here. And if we're looking at the two triangles, triangle MPS and triangle MPS, we should see that they are similar because we have this shared angle M, right? For the reflexive property, and so angle similarity. Okay, so what proportion do we need to set up? Well, we would set up the proportion for MPS is x, and for MQ would be x plus 7.5. Okay, because those are corresponding sides, so we'd say x over x plus 7.5, the corresponding parts, and that would be equal to 12 over 18. Okay, because the side of MR is 18. Okay, so this is the proportion that we need to set up, and let's solve it. Cross multiply, we get 18x equals 12x plus 84, 90. Make sure that's right. 12 times 7.5. Yep. Okay, and so we'll get 6x equals 90. Divide both sides by 6. X will equal 15. Okay. All right. Whew. X equals 15. All right. Now that's how we set it up using similar triangles. Notice triangle MPS is similar to triangle MQR. We use the corresponding sides, we set up a proportion, we solve the proportion for x. Alright, the theorem below allows us to set up a proportion in a much easier way. This works in all triangles. If a line is parallel to one side of a triangle and intersects the other two sides, intersects, there we go, sorry, I forgot where the space was. Intersects the other two sides, then the line divides those two sides proportionally. Okay. So what it basically says is if it's parallel to this side, then it's going to cut these sides in the same proportion. And so using that information, we can set up this proportion a little bit easier. We could have just said x over 7.5 should be in the same proportion as 12 over 6. And so when we set this up, we get 6x equals 90 and x equals 15. Yes. X equals 15, just like we set it up and saw this way. Okay, a little bit more visually pleasing too because it kind of seems like it's already set up for us, right? X over 7.5, 12 over 6. Okay, so let's look at another example of this using the side splitter theorem. Okay, so we have parallel lines, parallel to one side, intersects the other two, and so we know it should cut this proportionally. So we can say x over 16 equals 5 over 10. Cross multiply, that gives us 80 equals 10x. Divide by 10. That means x equals 8. Alright? So a little bit nicer than having to set up those longer proportions. Okay, looking at this top problem here, why can the side splitter theorem not be used in this triangle? Remember that the side splitter theorem has one important clause, is that the line that splits the sides has to be parallel to the third side. Okay, in this diagram, notice they did not tell us that these lines are parallel at all, so we do not want to assume that unless told to. Okay, now I'm going to tell you to assume that the line through the middle is parallel to the third side. Find the value of x. So now we're going to say, okay, this line is parallel, because that's the only way that we can solve it using the side splitter theorem. Find the value of x. And so we can set up this proportion as x over x plus 2 equals 2x minus 1 over x plus 4. A lot of x's here. Okay? So x squared plus 4x equals. Going to have to FOIL over there, so I'm going to write over here so I can make sure I get that done correctly. 2x squared plus 4x minus x minus 2. Combine my like terms. So that gives me 2x squared plus 3x minus 2. Alright, and so it seems like we're going to go into a quadratic, and so I need to make sure that I get it to equal 0. I'll try to keep x squared positive. So I'm going to subtract x squared and 4x from both sides. X squared minus 4x. And so that will give me x squared minus x minus 2 equals 0. I have to find the value of x, and so I need to find two numbers that multiply to give me negative 2 and add to give me negative 1. Those numbers, negative 2 and positive 1. Okay, and so now I need to solve this. If x minus 2 equals 0, if x plus 1 is 0, then I could get the answer that x is 2 or negative 1. Remember, I want to plug this in because if I get a negative value for any of these segments, it wouldn't make sense. And so negative 1 doesn't make sense. So x is 2. Alright? Yay. Quadratics and geometry, what more can you ask for? Alright, let's look at a corollary to the side splitter theorem, and it says if three or more parallel lines intersect, okay, gotcha. If three or more parallel lines intersect two transversals, then the segments intercepted on the transversals are proportional. Let's say that. So essentially, this is the triangle angle bisector, or sorry, the side splitter theorem without it being a triangle. You can even imagine it continuing all the way up until it's a triangle, but essentially you have a proportion that A over B should be the same as C over D. Okay. Alright. The triangle angle bisector theorem says an angle bisector divides the intercepted side into two segments that are proportional to the other two sides of the triangle. Okay, and so what that means is, in the same ratio that you see PR was one side and QS, the angle bisector, ran into it. So it says, hey, since this is the angle bisector, the same proportion that it cuts this into, so we'll say 8 over 5, left over right, is the same proportion that the sides of the triangle are cut into. Left over right, x over 6. And so 48 equals 5x, divide by 5. X will be 9.6. Pretty sure. Okay. And so x is 9.6. Alright. And then it says find the lengths of JP and TP given that KS is 5. Make sure that's 5. Maybe I should write it this way. 5. SQ is 3. QT is 4. And KJ is 6. So we want to find JP, which I'm going to mark with an X, and TP, which I'm going to mark with a Y. Alright, so this problem really is asking us both about the side splitter theorem and the triangle angle bisector theorem. Okay, so side splitter theorem first, looking at the sides, you see that these are parallel. This line, SR, is parallel to QP. And so we can use the side splitter theorem to say 5 over 3 should be the same as 6 over x. Cross multiply, 5x equals 18. That means x will equal 3.6. Which one is that? That's JP. Okay? And then to find TP, this is the side that is bisected, right? The angle bisector goes through this side, or not bisected, sorry, intercepted, because bisected means cut in half. This isn't cut in half necessarily. So we have, I'll say 4 over y, so bottom over top, should be the same as the bottom. Remember, we're going to take as 8, that whole side. 8 over, and then the top, in this case, we should know what this is now. Remember, this says x, but we found that x was 3.6. So this will be 9.6. So multiply that, that's like 38.4. Make sure I'm right. Nope. 9.6 times 4, 38.4 equals 8y. I'll need to divide that by 8, which is 4.8. So y is 4.8. Oops. Okay, so I used that. All right. And so there we have it. Okay, so that's side splitter theorem, that's triangle angle bisector theorem. If you can do those, then you're going to be in pretty good shape. See ya.